Good morning, sir.
Good morning. So let us start. Any questions from yesterday's class? Yesterday's class, was it clear?
Yes, sir.
So unit and dimensions. So measurement of any physical quantity involves comparison with a certain basic international internationally accepted reference standard called unit. So this is important because, like, for example, students who are studying here, okay, like a person, did BTech here, MTech here, and then for PhD, the person is going to, let us say, in a foreign country. So now, there in the foreign land, if the units are different, then it's going to be a mess for him. So therefore, the unit should be, by convention, universally accepted, and that should be the reference. There should be a reference standard unit for the entire measurements. So therefore, units and dimensions is a very, very important chapter. Okay, and that's the basic chapter. Okay, we proceed ahead. So therefore, meter, kilogram, centimeter, second. So these all are units. Some examples. Measurement of the quantity is mentioned in two parts. First part is how many times of the standard unit, and the second part gives the name of the unit. Like for example, 10 meters. So this is the first part, which is the magnitude. Meters is the second part, which is the name of the unit. Now, the number of words in English dictionary are many. All these words are made up of alphabets from A to Z. So similarly, in physics also, there are many, many terms, but all of them will be made up of these basic units. Likewise, in maths also, there are so many numbers, but from 0 to 9, these digits, they make all the numbers. Okay. So similarly, physical quantities appear to be very large, but then all of them, they are made from fundamental units. And these fundamental or base units, they are 7 in number. And this we have to memorize: length, mass, time, electric current, thermodynamic temperature, amount of substance, and the luminosity. Units of all other physical quantities can be expressed as combination of the base units. Example: velocity, displacement over time, which is meter per second, volume, which is meter cube, and such units obtained from the derived quantities are known as derived quantities or derived units. Okay, so it's fundamental unit or it's derived unit. Now, one interesting thing is that charge is not a fundamental quantity, but current is. Okay, so current is basically charge divided by time, q over t. So ideally, q should have been the fundamental quantity, but no, ampere, okay, which is uh, current, and I'm like, that is the fundamental quantity. So why is it so? Because of two reasons. It's very difficult to measure charge, but it's easier to measure current. Like for example, wood doesn't carry current. So we can tell clearly that the current through wood is 0. But when we have to tell charge in a wood, so now that for that we have to count all the electrons, all the protons, and then we have to find the net charge, which is very tedious and almost next to impossible thing. Very difficult. So therefore, current is chosen as the fundamental or the base quantity or the base unit rather than current. Also, the second reason is that the current was discovered earlier. Okay. And current can be like observed, current can be felt. Like we can get a shock when current flows inside our body. So that is so that's how current can be felt by us, but charge, it's difficult to detect. Is it clear? If yes, please raise your hand. Then there are two supplementary units, namely plane angle and the solid angle. Their units are radian and steradian, respectively. Okay. Now, what is a radian? Radian is the plane angle between two radii of a circle, which cut off the circumference and arc equal to the length of the radius. So, angle is equal to arc length divided by radius. So, if this arc length is r only, then theta will be equal to 1 radian, and that's what it is being said here. That when an arc equal to length of the radius is cut, then the angle is going to be 1 radian. Okay, so pi radians is 180 degree, 1 radian is equal to 180 by pi. So now radian is the ratio between the length of the arc divided by the radius. Steradian is the ratio of the surface area of the part of a sphere divided by radius whole square. And this will be seen when we'll be discussing solid angle, especially in the Gauss law. That will be very much required. Okay. Dimensions of a physical quantity are the powers to which fundamental quantities must be raised to represent the given physical quantity. Okay, so density is mass divided by volume, or mass divided by length cube. Okay, so that is kg per meter cube. So cube that, or like 3 is going to be the dimension. Okay, thus the dimensions of density are 1 in mass and minus 3 in length. Ratios are dimensionless quantities. For example, strain we have delta L upon L. So delta L, that is change in length, is also in meters. Original length is also in meters. So therefore it's dimensionless. Plane angle, solid angles, these are all dimensionless quantities. Okay. So now find the dimensional formula of the following quantities. Please find out. Good. Velocity. Perfect. Acceleration. Momentum. Force. Power. Ml square t minus 3. Work by time, or we can write force into velocity. Is it clear? Pressure. Good. Surface tension. Surface tension into length is equal to force. So therefore, force divided by length will be surface tension. Perfect. Universal constant of gravitation. Good. Impulse. Good. Now the properties of fundamental quantity. So they are independent of each other and they cannot be derived by each other. Okay. So like meter, second, kg. So none can be derived from the other two. Okay, an example is given that kilogram can never be derived from meter and second. The set of fundamental quantities can change also. Like it depends upon the reference. For example, if velocity and length are taken to be fundamental units, then time can become a derived unit. If it is clear, please raise it. Okay. What are the uses of dimensions? Conversion of units. So generally the units are going to be in SI and CGS system. And this knowledge of units and dimension helps us to convert the units from one dimension to another. Like Newton is the unit of force in SI unit, dyne is the unit of force in the CGS unit. So 1 Newton is equal to 1 kg ms minus 2, 1 dyne is equal to 1 gram centimeter per second square. So now 1 Newton, we can write it as 1 kg ms minus 2. The 1 kg is 1000 grams. So therefore 1 into 1000 gram into 100 centimeter per second square, which is equal to 10 to the power 5 gram centimeter per second square, which is dyne. So therefore 10 to the power 5 dyne. Is it clear? If yes, raise it. Solve this. (6.67 into 10 power minus 8. It is 10 power minus 7. Oh, 10 power minus 2. Okay, let us do this. Intermeters. Okay, this Newton has to be converted into dyne. Meter to centimeter. Kg to gram. Okay, so it should be not like this. So it will be 6.67 into 10 to the power minus 11 into. Now 1 Newton is 10 to the power 5 dyne. meters square. So 10 to the power 5 dyne. Meter square is 10 to the power 4 centimeters square divided by 10 to the power 6 gram square. This is 2, so here it will be 10 to the power 3. This goes and it will be 10 to the power minus 8. Mhm. Okay. We also got this only, no? Dyne centimeter square per gram square. Okay. 10 to the power minus 8. Okay, we proceed here. To check the dimensional correctness of the given equation, given physical equation. So now this also is a usage of dimension. Like for example, um, so so they are telling that every physical equation should be dimensionally balanced, and that's known as the principle of homogeneity. So there is a scientist, after so much research, the scientist said that I have found, one more value of gravitational force, which also tells gmm by r cube. But dimensionally, this is not equal to Newton. So therefore, it's going to be wrong. Okay. So on the basis of principle of homogeneity, because see, if this is Newton, force is Newton, so this entire thing must be Newton, and this entire thing must be Newton. Okay. But a dimensionally correct equation may or may not be physically correct, but a dimensionally incorrect equation is 100% incorrect. Okay. Like s equals ut plus half at square, and s equals ut plus 1 by 3 at square. So both are dimensionally correct only. But we know that this is valid, this is not valid. Okay. So therefore, that's what it is mentioned, that this is the limitation. Dimensionally correct equation may or may not be physically correct. But if it is dimensionally incorrect, then 100% it's incorrect. Okay, show that this is dimensionally correct. Do this. Good. So root L by G. So it's going to be root meter divided by meter per second square. So that's going to be seconds. Okay. Principle of homogeneity. So all dimension of all the terms should be the same. Solve this. Okay, let me solve this one. Then I'll give you other questions. So if you see here, the velocity is given like this. So velocity is meter per second. So this A must be meter per second, which is L t minus 1. Now BT also should be meter per second. So therefore B should be meter per second divided by T, which is meter per second divided by second, which is meter per second square. So therefore B will be L t minus 2. Now C by D plus T. So when D plus T is being added, so that means D has to be equal to T. And C by T is equal to velocity, which is meter per second. So therefore C is equal to meter per second into second. Gone. C is equal to meter. Therefore C will be L. Okay. So B is LT minus 2. A is LT minus 1. And D is T. A is LT minus 1, B is LT minus 2, C is L, D is T. Is it clear? If yes, please raise your hand. User dimension. It also can establish the relation among various physical quantities. If we know the factors on which a given physical quantity may depend, we can find a formula related with the quantity. Okay. Solve this. Let us do like this. So F is equal to force to the power A, length to the power B, mass per unit length, mu to the power C. So frequency is per second. Force is kg meter per second square to the power A. Length meter to the power B. And mu, which is meter per second to the power C. S minus 2A plus 2B. Okay. So A is going to be 0. Oh, I'm sorry. Mass per unit length, I have written meter per second. That's foolishness. Should be kg per meter. Kg per meter. So kg A plus C. Meter A plus B minus C. S minus 2A. So minus 2A is equal to minus 1. So A is going to be half. A plus C should be 0. So C is equal to minus A, which is minus half. And A plus B minus C also should be 0. So therefore, half plus B minus minus half is equal to 0. B plus 1 is equal to 0. So therefore, B is equal to minus 1. So therefore, this becomes root F L L to the power minus 1 mu to the power minus half. So 1 by L root F by mu, and I'm writing here K is the proportionality constant. So this is the frequency, how it is there. 1 by L root F by mu. 1 by L root F by K by L root F by. Is it clear? If yes, please raise your hand. Okay. You want to write it down or we proceed then? If you have written, then please raise your hand. Okay, we proceed. Shall we proceed ahead? Okay. Limitations. By this method, the value of dimensionless constant can't be calculated. That's true. Capital G cannot be calculated by this. Trigonometry, exponential, logarithmic terms also cannot be analyzed. And it cannot also be used if a physical quantity depends on sum or difference of two quantities. If they are multiplied together, as we saw here, then it's okay. But if it is addition or subtraction, then it's difficult to find out. Solve this. A better is solve this. Let us solve Riemann. So we have done the chapter. Solve. Let us solve few questions. It's D. So angular impulse will be I omega, or we can also do torque into time. Just like, impulse is F dt. Okay, so similarly, this is torque dt. Torque is Newton meter, dt is second. So kg m is minus 2 m second. So kg m square per second, which is this. If it is clear, please raise your hand. Solve this. Perfect. It is option. Good. Just see whether what we've written is matching. Okay. Let me proceed ahead. Solve this. Perfect. Just see if it is clear to you. Okay. Proceed. Solve this. Just see this. H is like in modern physics we will read hc by lambda. That's the energy. Okay, so from there we can get H, Planck's constant. So hc by lambda is energy. Okay, so from there also we can find out energy. Energy is Newton meter. So H becomes Newton meter, meter, meter per second. Gone. So Newton meter second, which is kg ms minus 2 into m into s. This becomes kg m square s minus 1. Good. Solve this. Perfect. That's 3 is correct. Solve this. Shall we solve JEE advanced one question or no? For Planck's constant, I'm writing here hc by lambda is equal to energy. Yes. FL by L, correct. It is F delta L, FL by A delta L. So, but yes, L and L both are in meters, so need not. A is going to be the answer. Shall we solve it? Okay, solve. Good. Perfect. Okay. So then we shall meet the next week. Thank you very much. Take care. Bye. Thank you.